Bismillahirrahmanirrahim. Rabbi zidni ilma. Quote of the day is the key to success is to focus on goals, not obstacles. Assalamu alaikum everyone. My name is Dr. Sadia Rafiq and under the supervision of Professor Dr. Sara Afzal, today my topic of presentation is probability, addition and multiplication rules. Learning outlines include the probability concepts, including probability experiments, sample spaces, addition and multiplication rules. Learning outcomes. At the end of these presentations, my colleagues will be able to describe concepts of probability, sample spaces, and addition and multiplication rules. Definition. Probability is the chance of an event occurring, and the event is the result of an observation or experiment or the description of an outcome. Probability experiments. Processes such as flipping of a coin, rolling a die is the puller of dice, or drawing a card from a deck are called probability experiments. A probability experiment is a chance process that leads to well-defined results called outcomes. An outcome is the result of a single trial of a probability experiment. Sample space. It is a set of all possible outcomes of a probability experiment. For example, if the experiment is a tossing of one coin, the sample space that it could be either head or a tail. So it will be two of the sample space. Then rolling a dice, it has sample space of 6. Then if there is answer either is a true or false, we have the sample space of true or false. And tossing two coins, so sample space would be head, head, tail, tail, head, tail, and tail, head. Example, rolling a dice. Since each die can land in different 6 ways and 2 dice are rolled, so we can have this sort of the combinations like dice 1, dice 2, and 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6, and so forth. Tree diagram. A tree diagram is a device consisting of line segments emanating from a starting point and also from the outcome point. It is used to determine all possible outcomes of a probability experiment. As you can see in this example, we are using a tree diagram to find the sample space for the gender of 3 children in a family. So as you can say, the first child was a boy, and in the next the next could be a boy or a girl, and then the third child again could be boy or a girl. So we have the outcomes of 8 different varieties, either boy boy boy, could be boy girl and boy, and so on. So this is known as tree diagram. Event. An event consists of a set of outcomes of a probability experiment. Types of an event: simple and compound. Simple event, an event with a single outcome, and when event with 2 or more outcomes, it is called as compound event. Two events are mutually exclusive events if they cannot occur at the same time. They have no outcomes in common. Interpretations of probability. There are 3 basic interpretations of probability. Number 1, classical probability. Number 2, empirical or relative frequency probability. And third is subjective probability. Starting with the classical probability, it uses one sample spaces to determine the numerical probability that event will happen. You do not actually have to perform the experiment to determine that probability. So the classical probability assumes that all outcomes in the sample space are equally likely to occur. For example, when a single dice is rolled, each outcome has the same probability of occurring. Since there are 6 outcomes, each outcome has the probability of 1 by 6. Similarly, when a card is selected from an ordinary deck of 52 cards, you assume that the deck has been shuffled and each card has a probability of being selected. And in this case, it would be 1 over 52. The formula for the classical probability is the probability of an event is number of outcomes in event and total number of outcomes in the sample space. The probability is denoted by this formula, number of outcomes and the number of outcomes in a sample space. This is called as classical probability. Probabilities can be expressed as fractions, decimals, or where appropriate, percentages. If you ask what is the probability of getting a head when the coin is tossed, typical responses can have any one of three, like one half, zero point 0.5, or 50%. These are all correct answers. Example, if a family has three children, find the probability of two of the three children are girls. So in this solution, the sample space of the gender of the children for a family that has three children has 8 outcomes. These would be the combinations boy, boy, girl, boy, 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 girl. See, and since there are three ways to have two girls, like this one, this combination, this one, namely this. So what would be the probability? 3 by 8. This is the number and this is the total outcomes. Probability rules. Rule number one, the probability of an event E is a number, either a fraction or decimal, between and including 0 and 1. It is denoted by 0 more than event but less than 1. So rule number one states that probability cannot be negative or it can't be greater than 1. Rule number two is if an event cannot occur, the event contains no members in the sample space, its probability is 0. The rule number three is if any event is certain, then probability is 1. And the rule number four is if the sum of the probabilities of all the outcomes in the sample space is 1. Complementary events. Another important concept in probability theory is that complementary events. When a die is rolled, for instance, the sample space consists of the outcomes. There is 1, 2, 3, 4, 5, and 6. The event A of getting odd numbers consists of the outcomes 1, 3, and 5. The event of not getting an odd number is called the complement of event E, and it consists of outcomes 2, 4, 6. So the complement of an event is a set of outcomes in the sample space that are not included in the outcomes of the event E, and it is denoted by the E bar. Since this is the rule for the complementary events, event 1 is minus 2, event complement. So if I state this rule in the words, if the probability of an event or the probability of its complement is known, either this one or this one is known, then the other can be found by subtracting the probability from one. So either if we know this one or this one, so we can easily calculate by dividing from it, subtracting it from one. This rule is important in probability theory because at times the best solution to a problem is to find the probability of the complement of an event and then subtract it from one to get the probability of the event itself. Probabilities can be represented pictorially by a Venn diagram. The given below diagram shows the probability of event, simple event E. The area inside the circle represents the probability of the event, that is PE. And the area inside this rectangle represents the probability of all the events in the sample space. So it is the probability of event, and if the sample space is 1 and it is of the complement, it is E bar. So simple probability is like 1, and by this formula complement ko 1 minus probability of an event. Second is the empirical probability or relative frequency probability. The difference between classical and empirical probability is that classical probability assumes that certain outcomes are equally likely. such as the outcome on a die is rolled, while empirical probability relies on actual experience to determine the likelihood of outcomes. In empirical probability, one might actually roll a given die 6,000 times, observe the various frequencies, and use these frequencies to determine the probability of an outcome. Suppose, for example, that a researcher for an American Automobile Association asked 50 people to plan to travel over a Thanksgiving holiday, how they will get to their destination. The results can be categorized in a frequency distribution as shown. Methods are by driving, fly, and train or bus. The frequency is 41, 6, and 30. Now, the probability can be computed for various categories. For example, the probability of selecting a person who is driving is 41 divided by 50, since 40 out of the 50 people said that they are driving. The formula for the empirical probability is the frequency of the class divided by total frequency in the distribution. This probability is called empirical probability and it is based on observations. It can be more can be explained by this example, as we can see the distribution of blood types. There's a total of sample of 50 people. 21 had O type, 22 had A type, 5 type B, and 2 had type AB blood groups. Set up the frequency distribution, find the following probabilities. Person has O type, person with A and B type. So the solution is this: the type is given and the frequency is given, as you can see. Then the probability of having a O blood group, total frequency of O is 21 and total number is 50. So after dividing this, we can have this. Then the probability of having A or B, as you can say, A has the frequency of 22 over 50 and B has the probability of 5 over 50. So by this, add the frequency of two classes, and this by we can calculate anything what we want, the frequency distribution. Law of large numbers. If the empirical probability of getting ahead is computed by using a small number of trials, it is usually not exactly 0. 0.5, your half of 50%. However, as the number of trials increases, the empirical probability of getting ahead will approach the theoretical probability of zero. 0.5. This phenomena is an example of the law of large numbers. Subjective probability. The third type of probability is called subjective probability, and it uses a probability based on an educated guess or estimate, employing opinions and inexact information. In subjective probability, a person or group makes an educated guess at the chance that an event will occur. This guess is totally based on the person's experience and evaluation of the solution. For example, a sports writer may say that there's 70% probability that the Pirates will win the pennant next year. A physician might say on the basis of her diagnosis that there's 30% of chance the patient will need an operation. Subjective probability, Bayes's method. Thomas Bayes was a scientist and it is used for the inferential statistics. The two important things in this theorem are the prior probability and the posterior probability. The prior probability of an event is based on prior knowledge, experience, or results derived from prior data collecting activity. Whereas the posterior probability of an event is a probability obtained by using new information to update or revise a prior probability. The addition rules for probability. The probability of two or more events can be determined by the addition rule. The first addition rule is used when the events are mutually exclusive. So the rule number one is when two events A and B are mutually exclusive, the probability that A and B will occur is like this. Probability of event A and B, A plus B. For example, a box contains 3 glazed donuts, 4 jelly donuts, and 5 chocolate donuts. If a person selects a donut at random, find the probability that either it is a glazed donut or a chocolate donut. And the solution, as we all know, 3 plus 5, total number of donuts in the box are 12. So the probability of glazed or chocolate is equal to glazed plus chocolate. So we'll add them and then we will divide it. So the probability is 2 by 3. The events are mutually exclusive. When events are not mutually exclusive, addition rule number 2 can be used to find the probability of the event. In this, the formula is like this: probability of A and B, probability of A plus B minus probability of A and B. This is the formula. And the example is like that. In a hospital unit, there are 8 nurses and 5 physicians, 5 nurses and 3 physicians are female. If a staff person is selected, find the probability that the subject is a nurse or a male. So the solution is that the sample space is shown: the staff nurses, 7 females, 1 male, total are 8 physicians, 3 females, 2 males, and the total is 5, and the total is. So by applying that formula, the probability of male, nurse plus male is equal to P nurse plus male minus P male nurse. So by this we can, by addition and then subtraction, we find it. In summary, then when the two events are mutually exclusive, we use addition rule number 1. And when the events are not mutually exclusive, we use addition rule number 2. This can also be described by this diagram. As you can see, the mutually exclusive events are like this: A plus B, and non-mutually are like, this is the area which is being exclusively. So the formula is this one. This is the area where A and B are there, and this is A and B. They are overlapping over here. Multiplication rule. Two events, A and B, are independent events. And in the fact that A occurred does not affect the probability of occurring B. When the outcomes or occurrence of the first event affects the outcome or occurrence of the second event in such a way that the probability is changed, the events are said to be dependent events. Multiplication rule number 1. When two events are independent, the probability is A and B is equal to A multiplied by B, probability of the event B. Example is, a coin is flipped and a die is rolled. Find the probability of getting a head on the coin and a 4 on the die. So, probability of head and a 4. Probability of head multiplication by probability of 4. It is 1 by 2 is 1 by 6 and total is 1 by 12. Note that the sample space for the coin of head or tail for the die is, head and tail key has 2 sample space, and for the dice it has 6 sample space. So we can further solve this like this: head, 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 all, and tail, all the sample spaces. The solution is 1 by 12, since there is only one way to get the head 4 outcome. This one. Multiplication rule 2. When two events are dependent, the probability of both occurring is, in this, there would be a division between probability B and A. Event A, B divided by event A. This can be solved as at an example is, at a university in Western Pennsylvania, there are 5 burglaries reported in 2003, 16 in 2004, and 13 in 2005. If a researcher wishes to select at random 2 burglaries to further investigate, find the probability that both will occur in 2004. In this case, the events are dependent since the researcher wishes to investigate 2 distinct cases. Hence, the first case is selected and not replaced. In this, you can see this case 1 and case 2. Case 1, probability case 2 divided by case 1, and this can be done by putting the values. The end. These are my references. Now moving towards the multiple choice questions. First question is, an event in the probability that will never be happened is called as unsure event, sure event, possible event, impossible event. Any answers? Okay, I describe it. These are the complicated MCQs that have, because that's why I have put explanation as well. Explanation is the answer is impossible event. An event that will never be happen is known as the impossible event. For example, tossing double-headed coins or getting tails in an impossible event. Rolling a dice and getting number more than 10 is an impossible outcome. So the answer is impossible event. Number two, what will be the value of P not event if probability of event is equal to 0.07? Any guesses? Okay, the answer is 0.93. How come? If the probability of happening of an event and that of not happening is, I have told you, event and non-event is equal to 1. And if we know any one of this value, we can calculate the second one. So the probability of no event is 1 minus of the event. And the event probability was 0.07. So 1 minus 0.07 is equal to 0.93. So the correct answer is 0.93. Question number 3. What will be the probability of getting odd numbers if a dice is thrown? 1 by 2, 2, 4 by 2 or 5 by 2?
A 1/2.
Yes. The explanation is this. The sample space of the dice is 6. Sample space is of 6. Event of getting an odd number was 3. Sorry. Mhm. So the event of getting an odd number was 3. Probability of getting an odd is equal to total number of favorable outcome divided by total number of outcomes. So outcome divided by total, it is 1 by 2. Question number 4. What is the probability of getting 1 and 5 if a dice is thrown once? 1 by 6, 1 by 3, 2 by 3 or 8 by 9? The answer is
1/5.
1 by 3. Sample space is of 6. Number of events is 2. So 2 divided by 6 is 1 by 3. Question number 5. What will be the probability of losing a game if the winning probability is 0.3, 0.5?
0.7.
3. Good. In this, as you can say, applying the same formula, we know the probability of non is 0.3, of the event is 0.3. We will subtract it and we will get this answer. Question number 6. In a box, there are 8 orange, 7 white, and 6 blue balls. If a ball is picked up randomly, what is the probability that is neither orange nor blue? I explain you. There's a total number of balls or sample space is 8 plus 7 plus 6. Total number of balls is 21. Let E is the event that the ball drawn is neither orange nor blue, or even that the drawn ball is white. There are 7 white balls. Okay. So we will divide 7 by 21 and the answer would be 1 divided by 3. Question number 7. In 30 balls, a batsman hits the boundary 6 times. What will be the probability that he did not hit the boundary? 1 by 5, 4 by 5, 3 by 5, and none of the above.
24/30.
Okay, let's see. It's 4 by 5. As we know, total number of balls are 30. Total boundaries batsman hit was 6. And number of the balls without boundary was 30 minus 6 was 24. So the probability when there is no boundary is 24 by 30 and the answer would be 4 by 5. Question number 8. The probability of winning the first prize in a lottery of a girl is 8 by 100. If the total of 6,000 tickets are sold, then how many tickets the girl purchased? 480, 750, 280 or none of the above? Let me describe it. The probability of winning the first prize of the girls is 8 by 100. Total number of tickets sold were 6,000 and the number of tickets girls purchased was 8 divided by 100 and multiplied by 6,000. So the answer is 480. A. Next question is if P is the probability of an event, what is the probability of its complement?
1 minus P.
Yes, you're right. The answer is 1 minus P. Last but not the least, if one event occurs, another event cannot happen. That is, the event that cannot occur simultaneously are called as exhaustive events, mutually exclusive events.
Mutually exclusive events.
You are absolutely right, Mehreen. Mutually exclusive events, events that are mutually exclusive, they cannot occur simultaneously. Thank you so much.